Section 3.3 in our textbook talks about how we would prove two lines to be parallel. And if you remember postulate 10 from section 3.2, it said if two parallel lines are cut by transversal, then corresponding angles are congruent. So before, if we had two lines and we were told that they were parallel, then we knew that angle 1 and angle 2 here would have to be equal. Now things change now because now we're going to talk about whether the converse will be true. So now we're asking, if we have two lines and we don't know if they're parallel, does having two congruent angles in these positions give us enough information to say that these lines are parallel? And the answer here is actually yes. And this is postulate 11, which says if two lines are cut by a transversal and corresponding angles are congruent, then the lines must be parallel. So if I have down here line A and line B, if I have this marked congruent to this, corresponding angles are congruent, so our conclusion is that A is parallel to B. That's postulate 11. We're going to be finding that most of the postulates and theorems in this section are converses of postulates and theorems from previous sections. This one's very similar. It says if two lines are cut by a transversal and alternate interiors are congruent. So for example, if this angle is equal to this angle, then if this line C and D, our conclusion is C is parallel to D. So we're saying that alternate interiors being congruent is enough to prove the lines are parallel. Theorem 3.6 says that the lines are cut by a transversal and same side interiors are supplementary. So if this angle and this angle add up to 180 degrees, then we would have two parallel lines here. Now, what I'm going to do is I'm going to say this is 130 right here, and this is 50 right here. That's enough to say that I'll call this Q and P. Q must then be parallel to P. Theorem 3.7 is another way to prove lines parallel, and that's to say that they're perpendicular to the same line. So if I have M and N, if I have this is a 90-degree angle, and this also is a 90-degree angle, I say, oh, this line right here is perpendicular to two different lines, so those lines are parallel. That's Theorem 3.7. Now, Theorem 3.8 and 3.9 are not ways to prove lines parallel. They're statements about what happens when we have a line and a point not in that line. Theorem 3.8 says, through this point, not in this line, there's exactly one line I can draw that's parallel to the line. So if I were to draw one line through that point, that's parallel to this line. I can't draw a different line that's parallel to this going through that point. Theorem 3.9 has the same point and line start, but it says only one line I can draw straight through that point that's perpendicular to this line. I can't draw two from there because those two lines wouldn't be able to share that point because they would have to be parallel because they're perpendicular to the same line. And Theorem 3.10 is another way to prove lines parallel. It says if two lines are parallel to the third line, this is almost like transitive property. Here we'll call these A, B, and C. Let's say I said A is parallel to B, and C is parallel to B. My conclusion is, since both of these are parallel to B, they're parallel to each other. And that's it. So basically, our conclusion here should be that there are 5 ways to prove lines parallel. So the first way, show that corresponding angles are congruent. Second way, Show that alternate interiors are congruent. Third way, show the same side interior angles. Supplementary. Fourth way, they could be perpendicular to the same line. And the last way, they could both be parallel to the same line. And this is probably the most important thing you could have in your notes.